Right, solving inequalities on page 76, section 7.5 is a bit like solving equations, only not. So that's extremely helpful, I'm sure. Look at the foundation videos, you see some basic ones. Let's do one or two basic ones here. Here we go. 4z plus 12 has got to be less than 0. That's question 1c. We'll take the 12 over and minus it. Get rid of it. It's got to be less than minus 12. Divide by 4. Z's got to be less than 12 over 4. 12 over 4. So z has got to be less than minus 3. That's the first one done. Let's just do... what else we got here? Don't need that one. Different sort of question. Let's do it over here. It says here 0 has got to be less than 3n, and 3n has got to be less than 11. And what I've got to do in question 4 is to list all the integer values such that this inequality is true. In other words, what fits between 0 and 11 that makes that inequality true? Well, let's divide by 3 on both sides. So 0 divided by 3 is nothing. 3n divided by 3 gives me n on its own, and 11 divided by 3 is going to be 3 and 2/3. So what did I do? I divided by 3 just to release the single n. Now 0 is less than n, so I can't say n is 0. I can start with 1, 2, and I can have 3, and these are my three integer solutions. 3 is less than 2 and 2/3, therefore 1, 2 and 3 fit comfortably between those two limits. Alright, and these are integers, and they're the only three that makes this inequality true. Pick another one. I think I'll do b. b says this, minus 4 has got to be less than 2n, and that's got to be less than or equal to 6. Well, divide both sides by 2. That's what I'm about to do now. So 4n divided by 2 is minus 2. That leaves me n on its own, and 6 divided by 2 is 3. So what are my answers? Minus 2 is less than n, so I can't have minus 2. So let's go 1 up then. So it'll be minus 1, 0, 1, 2, and it says I'm allowed to be equal to 3. Look, equals 3. So these are my 1, 2, 3, 4, 5 integer solutions. Alright, both negative and positive. I want to do C because it highlights something. C can be done over here. So I've got minus 10 has got to be less than or equal to 4 times n, and that's got to be less than 12. So dividing both sides by 4, I've got minus 2 and a half, I believe. Yes. 4 goes into 10 twice, 2 left over, that's right. Less than or equal to n, and 12 divided by 4 is going to be 3. Now, I know it says n is allowed to be equal to minus 2.5, but these are integers, so I've got to go the next one up, you see. So I've got minus 2 is allowed, minus 1 is allowed, 0 is allowed, 1 is allowed, 2 is allowed, but not 3. It says n has got to be less than 3. 1, 2, 3, 4, 5 integer solutions again. Okay, I'll leave that alone, and in the next page I'm going to do grade B ones now and solve these inequalities. Treat them like equations, but be really careful. Here's a nice basic one. I've got 7u minus 5 has got to be greater than 3u minus 1. Again, bring the u's together. 7u minus 3u has got to be greater than minus 1. Minus 5 take over, positive 5. So you've got 4 u's, so it's got to be greater than 4, ever so nice. So u has got to be greater than 4 divided by 4, which is 1. Unfortunately my u looks a bit like a 4, so sorry about that. Alright, so 4 over 4 is 1, u's got to be greater than 1. Let's try a dodgier one. Let's try this one underneath here. I've got 5 lots of w minus 1 has got to be greater than 3 lots of w plus 2. Again, just multiply it all out. We've got here 5w minus 5 has got to be greater than 3w plus 6. Again, bring my w's over and subtract. So 5w minus 3w is greater than 6. Take my minus 5 over and add it. 6 plus 5. So 2w has got to be greater than 11. W has got to be greater than 11 over 2. So w has got to be greater than 5 and a half. Question 4D presents a certain issue that I really have to raise right now. I've got here 3x minus 8 is greater than 8x plus 7. Now if we treat it normally, I'm going to say 3x, and you bring the 8 over to me and subtract, is greater than 7. Well, minus 8, take it over and add it. We end up with minus 5x's is greater than 15. Now under no circumstances do you ever divide by a negative value when playing with inequalities or trying to solve them. And the reason being, you won't get the right answer. Let's just see what happens if you go and divide by minus 5. I'm just going to highlight this to you. So I've got 15 divided by minus 5 as if it was an equation, and that means you're telling me that x has got to be greater than minus 3. So this is what we think is happening here. I need to test it out. If this is true, then if I choose a value greater than minus 3, then this inequality will be true. So give me a value greater than minus 3. I'm going to say let x equal 0, because 0 is bigger than minus 3. If I put a 0 in here, I've got 3 times 0 is 0. Goodbye. If I put a 0 in here, I've got 8 times 0 is 0. And I'm left with the statement that minus 8 is greater than 7. Clearly, that is not true. Therefore, we simply cannot divide by minus 5 to get an answer of minus 3, because I've proven that the answer we get isn't true. So back to this then. I've got minus 5x is greater than 15. In order to manipulate this little sum to get rid of the minus, I can take the minus 5 over x, the minus 5 over and add, and bring the 15 over here and subtract. So I've got minus 15 is greater than 5x. Is that alright? So I took the minus over and plussed it, and the 15 over and minused it. So I can now write it around the right way. 5x this time is less than minus 15. Okay? If minus 15 is bigger than 5x, then 5x is less than minus 15. I just merely wrote it around the other way. So x is now less than minus 15 divided by 5, and minus 15 divided by 5 is minus 3. Now I know we got minus 3 before, but look, this is an inequality. X is less than minus 3. I can prove to you that it works by going yellow. So here's the original. I've got 3x minus 8. It's got to be bigger than 8x plus 7. So let's pick a number less than minus 3. Let's go for minus 5. So here I go. I've got 3 lots of minus 5. Take away 8 has got to be bigger than 8 lots of minus 5. And then add 7. Well, 3 minus 5s is minus 15. Minus 15 take away 8 is going to be minus 23. Bigger than, well, 8 5s are 40. So I've got minus 40 plus 7. So minus 23, it's got to be bigger than minus 40 plus 7, that's minus 33. And this statement is true. And if it's true, that means x has got to be bigger than minus 3, and therefore that solution is correct. Sorry, x got to be less than minus 3, therefore that solution is correct. And the solution I was looking at and got it wrong earlier, x is bigger than minus 3, is wrong. And therefore I've proved that you don't ever try and divide by a negative value when solving integers. I think I'll do the last one because it's probably the hardest one in the book, and I'll turn over right now, see how it goes. Alright, okay, this is going to be 5f now. Here we go. I've got 7. Oh, it's not working, that, it's working yellow. I've got 7 minus 2 z's. Z's are right pain to see, aren't they? It's got to be less than or equal to 4 plus 3z's. Sorry, it's a little bit easy. It's meant to be the last one. It's easy. Right, I've got minus 2z's on this place. Take away another 3z's. Right, because it's plus there, take away minus it. Less than or equal to 4. And then the 7 goes next door and gets subtracted because it's positive 7. So I've got minus 5z's is less than or equal to 4 minus 7, that's called minus 3. Not working very well. Don't divide by negative whatever you do. You come over here and get positive. You get over there and get positive as well. So I've got 3 is less than or equal to 5z. Write it round the other way. 5z has got to be bigger. Oh, scribbling. 5z has got to be bigger than or equal to 3. Reading it around the other way. So z's got to be bigger than or equal to 3/5. Alright, 3 over 5, 3/5. And it doesn't have to be an integer. That's just the answer as it stands, and that's what I'm going to go with. I like question 6. It's a very creative answer, and I've not done one of these before, but it looks like fun to me. Right, so what I've got here, list all the pairs of positive integers x and y, so I've got x and y here, such that 3x plus 4y has got to be less than or equal to 15. Right, positive integers only. Are you ready? Well, I'm going to start with 1. So I'm going to say x equals 1. If x equals 1, I've got 3 lots of 1 plus 4 lots of y. It's got to be less than or equal to 15. Is that alright? So take my 3 over and minus it. My 4y has got to be less than or equal to 15, take away 3, which is 12. So my y has got to be less than or equal to 3. So here we go. I've got 1 and 3 works really well. I'll now try and do maybe a 2. So x equals 2. See if that works. I'm just testing it out. So x is going to be 2. So here I go. 3 multiplied by 2 plus 4 lots of y. Got to be less than or equal to 15. 3 2s are 6. So 6 plus 4y less than or equal to 15. Take my 6 over and minus it. 4y has got to be less than or equal to 15 minus 6, which is 9. So y has got to be less than or equal to 9 divided by 4 is 2 1/4. So what's less than 2 1/4? A whole number is 2. Is that alright? So there's two solutions. X is 1, y is 3, x is 2, y is 2. Let's try x equals 3 and just see what happens, shall we? So here I go. I'm going to try x equals 3. Work down here. So I've got 3 lots of 3 plus 4 y's. Again, trial improvement. It's quite allowed. Yeah, you've got to try, haven't you? So I've got 9 plus 4y. It's got to be less than or equal to 15. Take my 9 over and subtract it. Less than or equal to 15 minus 9. We're left with 6, I believe. Now we're going to divide 6 by 4. So 6 over 4, which is therefore 1/2. So what's less than 1/2? That's an integer. Answer 1. So these are all my answers. I can't go any further than that.